Do you know the many surprising connections between the deepest parts of space and the deepest recesses of our ocean? Both are cold, dark places where humans cannot breathe and where the pressure alone is enough to kill you. Both upset our normal experiences of gravity, providing explorers with a strange weightlessness or buoyancy if they could somehow survive being there in the first place. And both contain many unsolved, captivating mysteries. Our oceans are filled with life we've never seen before. And who can say what lurks in the unexplored corners of space? I was initially caught off guard when I heard that NASA had turned its attention towards exploring the Hadel zones deep in the ocean. After all, NASA is normally about space. What are they doing deep under the water and on Earth? I'm Alex McCone and you're watching Astram. Put on your diving gear and join me in a world of undersea facilities, uncanny life, and an environment so hostile, we've mapped more of Mars than of this terrain on our own planet. In 1957, a year before NASA was founded, a paper published by the Journal of the Royal Society of Arts claimed the deep oceans covered over 2/3 of the surface of the world. And yet, more is known about the shape and surface of the moon than is known about that of the bottom of the ocean. This was a reference to the fact that in the world before echo-sounding technology was commonly used to map the seafloor, we didn't know much about the topography of what was down there. We've come a long way since then, but while we have mapped the moon thanks to satellites and telescopes, we have still only mapped 23.4% of the ocean floor in high resolution. In fairness, this still represents an area of 120 million kilometers, about 3 times the moon's surface area. So the old saying no longer holds entirely true, hence why we can instead talk of Mars, which has a surface area of 145 million kilometers. But still it's a profound gap in our knowledge of our own world. NASA was founded in 1958 with the purpose of expanding human knowledge of phenomena in the atmosphere and in outer space, and developing vehicles and technologies that would help them to do so. Exploring the ocean was not originally on their radar or sonar. However, in 1978, NASA began monitoring the ocean with their first dedicated oceanographic satellite, CSAT, which was capable of collecting data on sea surface winds, surface temperatures, wave heights, and other features. This helped them learn more about our planet's oceans and their impact on the global climate. Still, some of NASA's most exciting foray into the ocean only began at the turn of the millennium. One way in which the sea can prepare astronauts for space is through simulated space experiences. About 8.7 kilometers off Calago in Florida is the world's only undersea research laboratory, Aquarius Reef Base. Built in 1986, it is a small 3-roomed habitat large enough to house 6 people at a push with a main room that combines sleeping and living quarters, an entry dock, and a wear porch for entering the sea around it. It was originally designed to help aquanauts remain at the bottom of the sea for weeks at a time through a technique known as saturation diving. By remaining at the depth of 19 m, the human body becomes saturated with gas dissolved in its bloodstream, which allows these researchers to stay at depth without ill effects for much longer periods of time, 9 hours for one dive, rather than 1 or 2 hours. This made it ideal for biologists wanting to study the local environment in situ. In 2001, however, NASA, along with other space agencies such as, realized that it made a great space training location. The cramped living conditions mimic those found on the International Space Station. So astronauts who spent a week at Aquarius Reef Base would get a vital taster of what life would be like up there. It also allowed them to practice performing experiments and generally get used to the expected and unexpected aspects of life in a hostile environment. NASA began the NEMO program, or the NASA Extreme Environment Mission Operations, and that same year began sending their astronauts to the habitat. There have been 23 NEMO missions since then, merging astronaut crews from a variety of different space agencies, which lasted up to 3 weeks. Astronauts there became aquanauts and got the chance to don deep space suits, getting a taste for what spacewalks might be like outside of our planet, readying them for the day humans return to the moon or go to Mars. This was not the only use NASA had for the ocean, however. Perhaps the most significant training was not for NASA's astronauts, but rather for the machines that would one day visit the largest oceans outside of planet Earth. Let's now go deeper and consider the exploration of alien oceans. Our solar system is home to many large oceans outside of Earth. Jupiter's moon Europa and Saturn's moon Enceladus, to name just 2, have significant bodies of water beneath their kilometer-thick icy surfaces. In spite of only being 1/4 of the Earth's diameter, scientists believe that Europa holds twice as much water as all of our oceans combined. This is an intriguing concept, as even though no sunlight penetrates down to those steps, the mixture of liquid water bordering a rocky inner crust would make both of these locations ideal candidates for life. Scientists have considered how to best test to see if life really has arisen in the oceans of icy moons. In 2024, NASA will launch the Europa Clipper with the mission to fly by the moon Europa and scan it to learn more about the depth of its icy shell, to try to determine the composition of its oceans, and generally get a better picture of the moon as a whole. However, Europa Clipper will only be laying the groundwork for future missions, which one day might see cryobots melting through the 10 kilometers thick icy shell of Europa, using nuclear-powered radiators to penetrate its oceans, and see firsthand what lies below. The deepest parts of the oceans on Earth are only 11 kilometers deep, but due to the gravitational differences between Europa and Earth, the pressure you'd experience between the two are much more comparable than you might think. Europa's 100 kilometers deep ocean is thought to have a hydrostatic pressure between 130 to 260 megapascals, which, if it existed in an ocean on Earth, would equate to a depth of around 13 to 26 kilometers. This is much better than if you'd had to go hundreds of kilometers down on Earth, but it's still no picnic. Pressure at the bottom of the Mariana Trench, the deepest place in our ocean, is 1,100 times the pressure on the surface, which is enough to crush the individual cells in the human body, or to implode most submarines. And yet, life survives there. And it doesn't just survive, it thrives. The deep-sea explorers of the Galapagos hydrothermal expedition in 1977, using a specially reinforced, remotely operated vehicle that could survive those pressures, were shocked to discover not a barren wasteland, but thriving ecosystems gathered around hydrothermal vents on the ocean floor down there. Tube worms, crabs, and fish were found in rich abundance. As scientists performed more dives, they found all manner of strange life forms down there. Shrimp like amphipods the size of your hand, giant ethereal big fin squid that were 8 m long and looked positively alien. In the depths between 6,000 and 11,000 m, in an area known as the Hadel zone, named after the god of the underworld, Hades, life had learned to adapt to conditions in ways no one could have imagined possible. And this incredible adaptability gives scientists a better understanding of what might be possible on other worlds. The deepest parts of the ocean are mostly found near the fault lines of continental plates, where one plate subducts under another. These deep trenches create a unique V-shaped environment that channels organic debris from above down into a sludgy pool. Whenever a carcass falls down there, the organisms in the Hadel zone are somehow able to quickly detect it and arrive within minutes. Other organisms rely on nutrient-rich liquids pumped out of thermal vents. If you added up all these trenches into one landmass, you would end up with an area the size of Australia, a whole unexplored continent. NASA wants to explore these regions using autonomous drones, perhaps whole swarms of them that would be able to detect locations of interest such as thermal vents, and would be able to map out the terrain using cameras and onboard AI similar to that used by the Perseverance rover on Mars. It's a challenging task. Not only would such a drone need to be able to withstand the excessive pressure, but the temperature around such thermal vents can spike to hundreds of degrees. Drones would need to be able to survive rapid temperature swings if they are able to survive. In 2014, one such deep-sea drone known as Nereus was sent into the Kurdic Trench off the coast of New Zealand. This is the area NASA has selected as testing ground for its new equipment. However, sadly, Nereus was not able to survive the pressure down there in spite of having succeeded on Hadel dives before, and it imploded. Pieces of plastic were later found floating to the surface. NASA's latest drone is Nereus's descendant, a smaller, lighter, autonomous submarine known as Orpheus. Orpheus has yet to enter the depths of the Hadel zone. Instead, it is being put through its paces in shallower waters. But if it works, its lighter design would make it easier to transport on a rocket to the oceans of Europa at some point in the distant future. Although this dream might not be so distant after all. In 2023, NASA's Planetary Exploration Science Technology Office gathered a team of 40 top researchers from multiple fields in the California Institute of Technology to discuss how close we might be to making this trip. A surprising amount of technology needed is already there. Take a walk with me through an ancient verdant land. So vivid are the colors and aroma of the entangled fauna that it takes you an age to notice something isn't as it should be. It's all quiet. The near absence of birds and mammals is the only indication that this land is dying, its fate sealed by the ending of an ice age. Waters are rising. The lush landscape below your feet will soon be 30 m below the surface of the Pacific. Any species able to migrate have escaped to continue their fight for survival in a warming, shrinking world. Those given life by their roots are held to perish by them. What is happening here? What can we learn from the history recorded deep in the melting polar ice is of vital importance. Because right now it's happening again. What is causing the ice caps to melt in the present? How will it affect the most powerful climate systems on Earth? And what hidden dangers does the ice contain? I'm Alex McCohen, and you're watching Astram. Join me today as we look at what makes ice such an interesting and crucial feature of our planet, and imagine a future wetter Earth, one whose existence may have already been forged. On Astram, we love to explore gigantic objects in our universe, whose scale through time and space stretch almost beyond our grasp. Look up towards Cassiopeia, and there is our closest galaxy, Andromeda, 2.5 million light-years away, 200,000 light-year from edge to edge. Yet, despite its magnitude, we can connect to it. So it's curious to me that looking only 80 years to our future feels too distant to connect with to understand that things we do today affect tomorrow's world. So let me take you there. At the beginning of our journey is the ice. Ice is a remarkable substance, one that can store vast amounts of energy. As a comparison, energy stored in modern electric cars capable of accelerating tons of metal to over 160 kilometers per h and carry both it and you hundreds of km could scarcely melt ice that would fit on its back seats. The energy storage capacity of ice is a large part of the reason that the climate has been so stable for the past 12,000 years. The ice is acting as a buffer against extreme temperature rises and falls. The Holocene has been a unique period in Earth's history for another reason too: the rise of human civilizations made possible through the development of agriculture. The Antarctic ice cap first formed around 37 million years ago, the Arctic 2.7 million as old as the light reaching us from Andromeda, and both caps are important for our stable climate to this day. Their historical size has largely been defined by Earth's position and tilt in the solar system. Movements that affect the amount of energy that our planet receives. These movements are known as Milankovitch cycles, which I've covered in a previous video. According to these cycles, the ice at the poles should be increasing. We should be heading into an ice age. The sea levels should be falling as the ice caps get deeper, but instead the polar ice is melting. Massive amounts of energy are being absorbed by the caps. And not only are we going in the opposite direction that the Milankovitch cycles predict, the ice loss is accelerating. Should all the ice melt, we are facing a 70 m sea level rise, which will flood all coastal cities on the planet. Fortunately, that degree of ice loss is exceptionally unlikely, but we do need to know how much sea level rise to expect, so that we can plan ahead and protect Earth's ecosystems. To predict just how much, we need to understand why and how the ice is melting. We know the release of greenhouse gases is a driver of today's global warming, overpowering the Milankovitch cycles, causing the ice caps to melt and the sea level to rise. But I was astonished to find out that this hasn't always been the case. Detailed records kept in the Antarctic ice core reveal that in the past, it was increasing temperatures that caused increasing CO2 levels. Cause and effect were flipped. But isn't that a blatant contradiction? Well, actually no. Each positively influences the other. It's just a case of which happens first. We see this play out as the increased temperatures of today's climate thaw the permafrost around the Arctic Circle, releasing long-stored carbon reserves, which in turn accelerate further global warming. The mechanism by which increased CO2 and temperature affect the polar regions reveals a complicated and fascinating climate system. Greenhouse gases trap infrared heat radiation emitted by the surface of the Earth. This heat is retained by the atmosphere and the ocean.